So now that we've talked about how to create fluxes, or one way of creating fluxes, let's talk about some of the basic things you can do to transform streams of data that flow through a flux after it's been created. And this will get us into something called transforming operators, which, as the little animation here, do transform stuff. And they can transform either the types in a flow or a stream or the values. And we're going to take a look at map and mapNotNull. So we'll look at map first. Now this should seem vaguely familiar if you're at all aware of how Java Streams works, because it's a similar kind of idea. So the map operator takes the items that are emitted and then transforms them. So it waits until it gets some stuff from the previous stage in the pipeline, and then it transforms those items. And the way it does it is it applies a function. You've seen functions before, basically a functional interface that's defined in modern Java that has a type that's the parameter and a return. And it applies these functions synchronously. So it does a synchronous transformation with a mapper function. Now, usually things will go as planned and everything will be hunky-dory, but there are situations where problems can occur. And so usually if something goes wrong, the way in which we tell the Flux to stop doing stuff because we've reached an input that doesn't make any sense, or we can't apply some operation for whatever reason, we can throw an exception. And we'll talk at length about how you handle exceptions later. But if you don't handle the exceptions through some of the other means we're going to discuss, then map can be terminated. In fact, the whole stream, the whole flux can be terminated. And what comes back is a so-called transformed flux with whatever changes the mapper function designated. Now, the thing to remember about map, and this is true both for Java Streams and for everything else that's map-oriented, the number of output elements generated through the transformation must equal the number of input elements, unless an exception occurs, but let's pretend like that didn't happen for this discussion. So here's an example where we take a list of big fractions, and then we go ahead and we multiply them together by some constant. And that will generate a stream of transformed results that have been multiplied and reduced. You can transform the type and or the value of the elements. If you don't transform anything, why are you calling map, right? So it should do something. So you can do a bunch of transformations. RxJava has a map operator that works exactly the same way. And this is also very, very similar to Java Streams map operator, which does essentially the same thing. There's another operator called mapNotNull. And this is a little bit of a quirk. But for various reasons, neither RxJava nor Project Reactor want to deal with null elements in their stream. So if you have a stream or a flux or observable or whatnot, and there's data flowing through it, if null elements occur, it's really bad. So in RxJava, you have to do some heroic things to deal with this. In Project Reactor, it's really quite simple. There's a method called mapNotNull. And what it does is it also works like map does, in that it takes a mapper function that it applies to every element in the stream. However, if the mapper function produces null values, those values are ignored. So if you have nulls, they're simply going to be ignored rather than what would normally happen, which would be an exception would occur. So you can use this method if there are reasons why nulls might occur in your input. And the most common reason for nulls occurring in practice is people have sort of this lazy shorthand way of saying, I don't really know what to do with this thing. I'm just going to generate null. It's kind of like if you've ever worked with statistics programs like SPSS or SAS. They usually have some like undefined value. If you have a table with values, there'll be an undefined value field or a type that indicates there's no value for this particular field. It's kind of like that. OK, so you can think of mapNotNull as being like map followed by filter. That would be the normal way you would do this in a Java Streams environment. However, since null is not a supported value, you simply can't filter it out, which is odd, but that's the way it works. So what you get is a transformed, you can also terminate. If an exception occurs, you can throw an exception. That's fine. And it'll return a transformed flux after applying the mapper that doesn't emit nulls. Here's a very simple example, which you can take a look at if you want to. It's in this link at the bottom of the slide. So just for fun, we're going to do something where we're going to generate a bunch of big fractions. So actually, I think we have, what, 2 big fractions. One will have the value of 10 over 3, and the other is 10 over 10, which would be 10. And then we're going to use mapNotNull, and this is kind of a crazy example done mostly just to show the point. We're going to see whether the big fraction we get from just equals the value 10, and if so, we're going to generate a null, because we can. And otherwise, we just pass the big fraction. Again, a somewhat contrived example, but the point is that what will be returned from mapNotNull will just be the big fraction that was non-null, not the null. So just illustrating the point. There are actually useful cases that are a lot more interesting than that one, but that's a story for another, probably for another class, in fact. So again, you can transform the values, you can transform the types, and so on. Oddly enough, and somewhat frustratingly, RxJava does not have a mapNotNull operator. I don't know why. And there's a couple of different ways you can solve this particular problem with RxJava. You can either program with optionals, where you basically wrap nulls into an optional and then filter out filter out any null or any empty optionals. But what a pain in the butt that is. Ugh, way more ugly than having a mapNotNull method. But you can do it this way if you're desperate. Or if you're really clever, you can write transformers, not to be confused with the techniques that are used for large language models. But these transformers can be used in order to be able to basically check to see what a value is, and if it's null, you can return an empty observable. Otherwise, you just return the result. It's kind of again, sort of a hack, but it works. And then you can create your own mapNotNull method that's a transformer in RxJava, and then you can use the compose operator in order to be able to use your custom-defined mapNotNull. So this is a way to be able to extend and enhance the features that come out of the box with RxJava. You can do the same thing with Project Reactor, but we don't need to for this case because they support the mapNotNull operator directly. So that's the end of the discussion of transforming operators in the Flux class.